as you know, like on this every Friday we have to solve two problem and related theory part also I have to discuss related to that question. But apart from this, we are taking some separate class. In that class, we are covering the theoretical part. If you have any doubt, you can join and you can ask. Other than that, also I will discuss some favorite topic of gate of strength of material. So today we are going to solve two problem again, and this problem is not like a very hard problem. It's a very basic question related to simple fundamental of strength of material. So here, this problem and related to this problem, whatever theory is required, that we will discuss. So the first problem here, it is given a cylindrical transmission shaft of length 1.5 meters. So just stick with the question. Cylindrical shaft, okay, and length is 1.5 meter and diameter is given 100 mm, 100, and this one is 1.5 meter. Is made of a linear elastic material. In the first class we have discussed about the linear elastic material, okay. So like up to this thing, proportionality limit, we are talking about that young modulus is constant. Related to that we are discussed. And shear modulus, like you people are knowing about the shear modulus, G value is given while operating at RPM. While operating at 500 RPM, this is given. The angle of twist is also given. So the power transmitted by the shaft at this speed is what? It's a very, very basic question. And see, while solving the problem, I will tell you something, like you put your concentration or focus what they are asking. Don't think other, don't means digress the problem. Just focus here. They are asking power transmitted. So what is power transmitted? Like power transmitted P equal to 2 pi NT by 60. Anyone have doubt in this formula what I have written, from where this is coming? Any one of you? I think most of you. Yeah, tell me. Ah, correct. Okay. Any other means, okay. Let me explain this. What is power? Power, like power is nothing. Power is what is the unit of power? First, we'll start from very basic. Unit of power is what? Okay. See, I will tell you something. Power, even in IC engineering, mechanical engineering, electrical engineering, electronics engineering, everywhere power is same. Nobody will change the this thing, unit and concept of power. Power is nothing but your power, P equal to force into velocity. That's all. So you don't confuse about power, like here this formula, somewhere the other formula will be there. Not like that. Okay. So somebody is there in the meeting. This thing. Let me add him, because today itself I am late. Okay. So power is nothing but your force into velocity. In mechanics, basic mechanics in 12th class, whatever you have read in 11th, 12th class, the same thing. Okay. So now, uh, from here to here, how we are reaching from here to here. Okay. So you can write simple. Power equal to force into velocity. Also one formula you are knowing, torque into omega. Omega is your what? Angular velocity. This this is angular velocity. Okay. This is radian per second, and this is meter per second. Okay, the tau into omega is also a this thing, your power. So uh, tau into omega, whatever you can, that multiplication factor and all these things will come later. First, we are going to we are trying to relate the basic fundamental from here to here, how we are coming. See, what is this omega? The omega is nothing but one formula is there, like V equal to R into omega. You people have read this formula, right? So if you are putting this here, F into R into omega, what will be there? What will happen? This is nothing but your torque. F into R, F dot R, F, like this is a, like I am everything I am writing in scalar. Like this is vector quantity, this is vector quantity, but I am writing magnitude. If you are going to write this R into omega thing, then this vector notation will come. Simply, I am trying in the vector magnitude way. So this R, this one, this this thing is nothing but your torque, and this is the omega. So from here, how we reach here, and from here t into omega, how we are reaching 2 pi n t by 60, we'll see. So omega is your radian per second. Omega is your angular speed, angular velocity, and like omega is your nothing but 2 pi n by 60. So suppose I will explain how this is happening. Suppose this is a this is a circle, and this is the like you are here. Okay, you are here. One cycle, one full cycle, you are completing in t time. Okay, one full cycle. So t time. So simple logic is very simple. In 1 second, how much revolution is there? N is nothing but RPM. RPM. 1 second RPS or RPM. Okay, so don't confuse. If it is RPS, revolution per second, then 60 will not be here. If RPM, then 60 will be there. Okay, how this is coming will discuss. So suppose in 1 second, how much revolution is there? Suppose a small n. In 1 second, this much revolution is there, a small n. So what is the angular speed? Angular speed is nothing but how much angle it is covering in time t angle. So in 1 second, how much angle it is covering? In one full rotation, it is covering 2 pi. In one full rotation, 2 pi. So 2 pi is 2 pi, and this is what? N. N is number of revolution. In one revolution, 2 pi, and in n revolution, 2 pi n. This is the angle covered in 1 second. So 2 pi n will be nothing but your omega. Okay. And now this is in 1 second. If I am talking in 1 minute, revolution, in 1 minute it is covering n revolution, capital N, in 1 minute. So in 1 minute, how much? 60 seconds. It is covering in 2 pi into n angle. In one revolution, 2 pi is the angle. And in n revolution, 2 pi into n is the angle. So in 1 second, how much it will cover? 2 pi n by 60. So in 1 second, how much angle it is coming? That is nothing but your angular speed, that is omega. Okay. So omega is nothing but 2 pi n by 60. Here it is provided that n is in RPM, not RPS. If it is in RPS, then 60 will not be here. Here in the question it is given 500 RPM. Up to here, any doubt? I am going a step by step so that there should not be any confusion. Any doubt? Okay, so now see, we have to find out T. T is nothing but 2 pi n t by 60. This is power. So N is given in the question. T is not given in the question. So how to find out T? Question. The now next question is how to find T. T is what? In like torsion thing, you have this formula is very known to you people. G T by G theta by L equal to tau by R. I will derive this formula in the theoretical class, but for now, I believe you people are knowing this formula. This is derived from the torsional part. Okay. So, yeah. This one is your J is your what? Pi d to the power 4 by 32. Okay, this is for shaft, circular shaft. This is a circular shaft. Circular shaft. Diameter is d. This is diameter is d. This one is diameter. Okay, so what is the polar moment of inertia? Your J, and that will be, if you will derive this with the basic formula of moment of inertia, it will come pi d to the power 4 by 32, and that part I am not going to derive because this is a very fundamental. In 12th class you people have derived. So J you can find how I pi is given at 3.14. D is also given. D is how much? 100 mm, 32. So J you can find. So from this formula, you can write T by J equal to G theta by L. G theta by L. Now you can see J you can find because diameter is given. G is also given. Theta is also given. L is also given. Then you can find T from here. Okay. You can find T. So So you can find T. So how we can find T? T J G theta by L, and from this formula we are going to find G theta into J by L. This one. Okay. Now you have G, you have J, you have theta. But where people are making mistake, now the rule of mistake. Theta is given how much? You in the previous question you can see theta is given 0.5 degree. So never forget to convert it in radian pi by 180, because this is in degree. You cannot put directly here, because whatever your calculation you are doing, that here in numerical part you have to put theta in a radian. So don't forget. So you are going to put this. Now J is what? J is your pi by 32 into d to the power 4, and pi by 32 into d to the power 4 is d is what? D is zero point 0.1 mm. So zero point 0.1 meter. So this will be like that. So zero point 0.1, yeah. So this is your J. Now the thing is that you know theta, you know J. L is also given. L how much? L is 1.5 meter. So L is 1.5 meter. So you got what is T. Now, if you will put everything, you will get. If once you will come to know what is D, simply nothing you have to do. 2 by nt by 60. You know this formula, and from where this formula came, derive that formula. You put the value, you will get the answer. Simple, very simple. Very simple question is there. So directly you will get it. Okay. So you can calculate. Okay. So it will, if you will put some all the formula, it will come something. The numerical value, if you are putting, it will come something 238 point something 64 or something, it will come. I before taking this class I solved numerically, so it is coming something like this much. So you can cross check. Okay, numerical value, just a calculation. A concept part I have explained, but just a calculation, okay, either it is coming this much or not. Any doubt? Any doubt you can ask. Sir, it is coming to 30. Yeah, tell me. Somebody is 238. Huh? You just calculate, calculation part, whatever it is coming is correct. Okay. Just a calculation. Like what you are telling, 230, 230, 238.88. Okay. You just cross it. Like all the value you put, how much J is coming, and then how much T is coming. Have you calculated how much T is coming? Yes, sir. 4.56. Okay. 4.56. This will come kilo Newton meter. Okay, and okay, then T you know. So if you just have to find out what is this 2 pi. N is your 500, right, into 4.56 into 10 to the power 3, 2 pi nt by 60. So this value will be your answer. Okay, and whatever it will come 238 or point something, you just check. Any doubt? So what you learned from this question? I just cross check. You have learned from this question what I told you. Like first focus, or you concentrate what they are asking in the question. So your first thing is that what they are asking, and what they are asking is power transmitted, and you will start from here. While solving the problem, don't bother about the other thing, what is given, what is not given. In one question 100 thing will be given, out of maybe only 50 will be used, the rest 50 will be unused. Intentionally they are giving, like to confuse the people. This is also happening. Okay, so don't confuse. Any doubt you can ask. Any doubt? If you have doubt, you can ask. Okay. So we'll move to next question. So I will once more I will repeat. Okay. So what I'm trying to say, like in any question, you just first focus what they are asking. Final statement, what they are asking. Okay. Here in this question, they are asking for power. So for power calculation, what parameter you need? This is your next step. Okay. Next step. For power calculation, what are the requirement of that other parameter? So you need N, like you need N, you need P. Okay, so N is given. Now P. P is not given. So next step, how to find P? Okay, so P is your like nothing you know this formula T by J equal to G theta by L. This one. So now for this equation, what are given, what parameters are given and what are not, what is not given in the question. So G is given, theta is given, L is given, J is not given. So your next target should be how to calculate J. So J is your nothing but pi t to the power 4 by 32. This is the standard formula for a cylindrical bar having diameter d. So now d is given. So everything is known now. You just put in formula power is nothing but 2 pi n t by 60, 2 pi n t by 60 and put this value and calculate. Don't digress the problem and don't think about the other parameter. What so many things are given in the question, like here, like in the linear. So you people will be confused, like linear elastic material, any use of this statement? Nothing. Okay, so don't, like some parameter or something it will be given in the question for, means just for you to think something other than the answer, means original answer. That type of things people are doing in gate. Okay, so don't confuse about that. So we'll move to next question. Any doubt you can ask. Shall we start? Answer was it was coming something 238.88 or something, right? 230.238 or 64 something. You can cross check that answer. Don't bother about the answer. Your answer is going to be 2 pi n. N is what? 500 rpm. T is coming 4.56 into 10 to the power 3 divided by 60. You solve this. Okay, you this equation, this expression, whatever value will come, it will be the answer. So I will solve it for you. 2 into pi into 500 into 4.56 into 1000 divided by 60 divided by 1000. So it will come to 38 point. Somebody are getting 238.88. Somebody is getting 238.64. Somebody will get also 238.76 also kilowatt. Okay, so uh, don't worry about this parameter, because in NAT problem they are giving a range from this value to this value. In between whatever value will be there, that will be correct. Okay, so that in up to 2 decimal whatever is there, you just the range will be given. And why this is coming different, because of pi. Somebody is taking this, somebody is taking 22 by 7, somebody is taking something. So that calculation, because of that variation, pi value, or if you have approximation you are doing with the numerical value, then this variation will come. So don't worry about that. 238.886476 something it is coming. So the correct answer will be 238 point. What is that? 238 point. After solving, I am getting 238.76 with my calculator. So, so we'll start this question. Here, can I start this question? Yes, sir. Okay. So now the next question is given, like a cylindrical bar. A cylindrical bar having length. See, the previous question and in this question, what is the similarity? Same thing, like a cylindrical bar was also there, diameter and length, everything is like given. Okay, so only a small thing change. Like, see, in this question, what they are trying. Why I have chosen these two questions, because they are very much similar. That was related with the torsion and that is related with the tensor. That's all. So see here, cylindrical bar of length is given 5 meter. Cross sectional area is given. Cross sectional area is nothing but your this area. This is cylindrical. So this is cylindrical means circular cross section will be there, circular like this. Okay. The bar is made of linear elastic material. Again, it is given linear elastic material with a density. Density is given. So why they are giving density? I don't know. We'll see what is the use of this density. So density is nothing but your mass by volume. So something it will be related to calculate the mass or volume. That's why, like, you will know the density mass by volume. So either this will be required in the question or this will be required. That's why they are giving this. Okay, so you have to relate how to find out means original weight means how to find out the use of the variable. Or there must there will be like something will be there in the question which can relate with the answer. Like here, rho is your density. E is young modulus. Young modulus is given 670 GPa. Subjected to like this. In the given figure, it is given like this. So they are saying due to the uniaxial tension due to the self weight. So what is the first question? What is given in the first thing? What is given in the question? This bar is given, and due to self weight, some weight is there. What is the weight? Weight is nothing but mg, and due to mg, and this mg is where it is acting at the center of mass, and it is acting down direction. So due to this mg, there is some tension in the bar. Due to that tension, there will be some self deflection. Means deflection will be there. Self weight, due to self weight, some deflection will be there. This is the deflection, and due to that deflection, there will be some energy stored in this bar. What is that energy stored? That is nothing but your strain energy, because when you are putting some weight, there will be some strain in this body. If a body having a strain means you are giving some energy. Simple, like in the first class I discussed about the strain. Like a body is there and you are deforming this body, you are applying some load, and now this body is becoming like this. Means you are deforming, you are putting some external energy to the body, and due to that external energy, body will deform. Okay, so same thing here. Due to self weight means already some weight is there with this mass, with this bar, and due to that self weight, body is deforming. What type of deformation? Self weight, it is elongating. It is elongating, the length is increasing due to the self weight. So that because of that deformation, some energy is stored in this one, and they are asking what is that energy. Answer question, how means what I am trying to say, you got it or not? Any doubt? No doubt. Okay. So see, in the question it is given L. L is your nothing but 5 meter. Cross sectional area, they are giving cross sectional area is 10 meter square. It's a big cross section. Okay. E, E is given. E is nothing but your young modulus 70 GPa. Okay. And rho is density is nothing but 2700 kg per meter cube. Okay, and G is given. G is nothing but your gravity, 9.8 meter per second square. That's all. So, any one of you know which material is this? This is not related with the question. I am asking outside this question. What material is this? Can anybody guess? Steel, copper, chromium. What metal? Yes, correct. Aluminum. So this is your. What do you know? Why I asked this question? Because I just wanted to check your intelligence. Like people are asking sometimes, you have two material, like the row will be given row 1, row 2, and row 3. Okay, and somebody will say like one material is Fe, one material is copper. This is not related with this question. I'm just something other than this question I'm trying to tell you. This is Fe, this is some, suppose this is cobalt, manganese or something, or some aluminium like thing. So you know aluminium, density of aluminium is, means a rough value. But aluminium is a lightweight material, so density will be less. For this thing, iron is still this density will be 7 to 8, 7 to 8 gram per centimeter cube. So 700 to 800. It depends on the carbon content on other material like stainless steel, mild steel. So it depends on this. So for this, the density will be 7 to 8,000 kg per meter cube. For aluminum, it is 2700. So in objective question, sometime people are also asking, okay, like aluminum is there, iron is there, cobalt is there, copper is there. They will ask which one is the lightest material. So how to find out? So you just have to recapitulate your concept, like what is the density? What should be the density? The minimum density. Which material should have minimum density like that? Aluminum is lightweight and aluminum density is 2700 kg per meter cube. So you just, I'm not saying you remember this. You just keep this thing in mind. Sometime you will come across this type of question. Okay. So now come to the question. So we have to find out what is the strain energy stored in this body due to self weight. So any one of you know what is the strain energy? Strain energy you people have calculated. Uh, Simple. First of all, we'll calculate what is energy. Energy is nothing but force into displacement. You have rate this in force into displacement is your energy work done. This is the work done. Integration from some value to some value. This is your work done. So if you will convert this thing in, see again, concept is same everywhere. Even in a state of material theory, machine, engineering, mechanics, everywhere. Concept is same. What is work done? Force into displacement. Okay. So force into displacement will be work done here also in term of stress and strain. How you are going to convert, formula will be same. You just have to convert in term of strain and stress and strain. So you know, for gradual loading condition, the gradual loading, the energy is 1 by 2 into p into deflection is suppose delta L. This is your energy gradual loading. That's why I'm taking average of load equal to. So, how to convert in term of stress and strain? So, in term of stress, you have to find out P by A term. So, if you are multiplying by A here, you are dividing with A, so you have to multiply with A here also. So, this is nothing but what? This is your stress. So, this is stress, and this is what? This one. This one is your volume. This one is nothing but your volume. So how to convert in a term of stress and strain? Strain, as you know, strain is delta L by L. So it is a strain. So delta L you can convert delta L equal to strain into L. Okay, so here you can put delta L instead of delta L you can put strain into L, and A into L will be your volume. Also, this is unit of volume, but this is instantaneous increase. But if you will convert in general form, you are going to do like this: E equal to 1 by 2 into P by A. You are dividing with A, then you have to multiply with A here also, and delta L, and you are dividing with delta L, then you have to multiply with L here also. So these two term, A and this one, we are adding, means we are dividing and multiplying. So the effect will be null. Okay. So now you can change in term of stress. 1 by 2, this is what? P by A is stress. Okay. And delta L by L is strain. And A into L is what? Volume. So this is your strain energy. Formula from where we have started. F into dx. And where we reach? We stress, strain, everything. So this is volume. So you people are generally writing 1 by 2 stress into strain like that. This is per unit volume. This U is nothing but E per unit volume, means A into L. You are dividing this side, and whatever term will be remaining here, this is nothing but your energy per unit volume. Now come to the question what they are trying to say. So uh, like 1 by 2 sigma into strain, this is your strain energy per unit volume. Per unit volume. Now you have to, in the question, what are the given thing? In the question, their self weight is given and elastic modulus, length, cross sectional area, density. In term of that part only, you have to convert the formula. Then only you can use that parameter. So to convert that. So uh, uh, we converted that force in term of space. Now you go back and you put the value of a space and a strain, then you will come to know that u is nothing but p square into dx by 2ae. And how this is coming, I hope you know this thing, or shall I derive? From where this formula is coming, I will give you a homework for this. From where this formula is coming? This formula is coming from the basic fundamental f into dx integration from 0 to L. From here, this is coming to here. And this link is your intelligence power. That's all. a smart student who is preparing for gate, and like people who are taking for granted, that is the difference. Like they know for this formula from where this is coming, they know how to derive all these things. Okay. And means people who are taking for granted, they will remember this is the formula. They will what thing will happen, like they will remember, and that what mistake they will make, where to use this formula and where it will be applicable, they don't know. So if you know from where this formula is coming, what is the foundation or base of this formula, you also know where this formula will be applicable. So this formula will be applicable everywhere. This is the basic fundamental. This is the definition of work done or energy. This is the definition. And from this part to this part, where here we are reaching. So now I'm just hoping you people are knowing this formula. If you don't know, try to derive this formula. Okay. And if you still you are unable to derive or you have any doubt, we can discuss in the next class, Sunday class, and I will derive this formula also. For now, I am just writing e square dx by 2ae. Why I am writing e square dx and integration? If any formula in a standard material or any subject, if some integration term, differentiation term are given, so just in one line, you just have to understand something is variable. Something is variable. So here, 2 constant, e constant, a constant. P will be function of x. And x is what? Along the length, like your body was like this. And suppose this is the x axis, like in this direction, x is there. So along the length, P is variable. That's why I am writing integration. Why P is variable? Suppose up to here, I am trying to calculate at this part, what is the weight up to this, but what is the weight, and because of that weight, how much deflection is coming or strain energy is stored. So up to this part, if you will make a free body diagram, below this line, whatever mass is there, due to that mass only, this body will be extended. This body has also some mass, but at this point, only this mass is exerting some force. And that force is nothing but the mass of this into G. Suppose this is M1. So M1 into G will be, means this will be the cause. This force will create some deformation in this body or strain or strain energy. This force will be the main reason for this. If you will shift this plane here, then your mass will change. Now, if you will make free body diagram, your mass will be more. Okay. So now, in this body, in this part, due to this weight, this whole weight, if you just hang it here, force. So due to this weight, there will be deformation in this part. So according to this shifting or according to the adjustment of this line, as you are going up and up and up, okay. So your mass force is increasing. Maximum force will be here. So how? So this is the line where you are hanging your weight, and the whole weight is exerting force here. That will be nothing but your mg, whole mass. And as you are going down here, so little less mass, going down little less mass. Here there is no force. If you are at the end of this material, there is no force. So you have to integrate from this point to this point only, 1 to 2. That's why I have taken 0 to L. Okay. The P is variable. So what is the value of P? So how to calculate P? If this is a linear variation, means you just have to find out. I will give you just a hint, like P, how to calculate. Suppose the whole mass of the body is W. W is nothing but mg, whole mass. And as the length is increasing, means what I am trying to say, this is the bar, this length is L. This length is L. So per unit length, what is the mass? Per unit length mass will be W by L. So as length is increasing, your mass is increasing. So if you just W by L is there and you just multiply with X here. So if X is equal to L, what will happen? If X is equal to L, this will be cancelled. Then your mass will be, weight will be W. If X equal to L by 2, what will be the weight? L by 2 means up to here. So W by L into L by 2. So this will be cancelled. The mass will, weight will be W by 2. So up to here only half mass you are considering, and due to half mass weight will be mg by 2. So this is a linear variation. So you just have to consider in here you are taking P now. So P is nothing but W by L into X, and this is the square. Okay, and this is X delta dx divided by 2 into A into E, and you have to integrate this part because this is a constant, and you put 0 to L. Okay, 0 to L. See, in most of the question, you will get a direct formula. Direct formula you will get it. And what is the direct formula? If you know how to derive, for you question will be very easy. Very easy. Okay. If somebody have just remembered that formula, somebody read formula and they just make it like, okay, we'll remember this. Then the problem will be that in in some questions they are able to apply, in some questions they are not able to apply. The thing is that because the physical significance or physical feel will be not there, because they don't know from where this formula is coming, and they have just remembered that. So I request you all people, if you have time and if you are really interested, you try to relate from where this formula is coming. Everywhere the basic fundamental will be common everywhere, even in thermodynamics, heat transfer, fluid mechanics, strength of material, theory of machine. The basic fundamental will be everywhere the same. So let me finish this problem and then we will discuss little bit something other than this. So this will be the thing. So now you have to integrate it from 0 to L. So what will be happen? This will be W is your total mass. It is constant. L is constant. This will come out. So W square L square x to the power 2. So integrate, if you will integrate it, then what will happen? X cube by 3. And in denominator 2 is there. So 2 into 3 26. So I am writing direct here. The direct it will come W square W and x square, it will put value of limit value 0 to L, then numerator it will come something LQ, and denominator will be L square. So only L will come on the numerator, and here it will come 6AE. Any doubt? Any doubt? Okay, thank you. Now you come to the final, means in the question what they are asking. What in the question L is given, E is given, A is given. Now W is not given. I told you initially why row they are giving. So there is some purpose of row, and that purpose we figure it out. Like they are asking what is W, and for finding the W we need M into G, and G we know. So for finding M we know rho. Rho into what? Rho into volume is nothing but your M. So here there is a use of rho. So you just have to put the value of rho here. So you can like we'll go to the next page. So finally we have calculated the stored energy is nothing but it is coming W square by W square L into 6AE. This is coming, and we have to find out the value of this W, and W is nothing but M into G. So now we have to relate it. So one parameter is there, like sometimes people are writing like a specific mass or a specific weight, something like gamma. They are relating with this, and gamma is nothing but your mass, like mg by volume. This is just a parameter. If you don't want to use, don't use. You just go with this one only. I'm just why I'm this is volume. So why I'm writing this, because in some question or some solution, if you will see solution online, they will introduce this parameter, and what they are writing directly here, they are writing rho into G. So you will be again confused from where this parameter is coming. This is coming from simple weight by volume. So if you will put weight by volume, this is a specific parameter, like a specific a specific weight. Okay, so a specific weight is nothing but your uh, here, sorry, uh, yeah. So mass is nothing but rho into volume. into G by volume. So V will cancel and you the remaining term will be rho G. So sometime they are directly writing rho into G is a specific and they are writing this as a gamma. So you can use it, you can relate it. How you will relate? Because here see you have mass. So mass you can write rho into V into G like W. This is going to be W will be like this. Rho into V I am writing instead of M. And now you have everything. You have everything. Rho you have, G you have, V also you have. How? Cross sectional area you have, length you have. Cross sectional area into L will be your volume. So now you know everything. So directly you can find out W and you know L, you know A, you know E. You put the value, all this value in U, you will get the answer. Any one of you have solved this problem? 2.08 Joule. Correct. So you people can cross check this is coming or not. How you have to cross check? You just have to put all the value in this formula. And how to get that all value I have already discussed. So now I will tell you something. Uh, First of all, let me know any doubt is there or not. Other than that, I will tell you something. Any doubt? Any doubt? No, sir. Okay, then I will stop. Yeah, tell me. Yeah, 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 yeah. I will take your question. Okay. Let me stop the recording and we'll start with the question because already we are running late. Yeah, yeah, I will.